The idea of life beyond Earth has mesmerized humankind for generations. The possibility that intelligent beings elsewhere in the cosmos might be transmitting signals, possibly at the exact time we're listening, feels both hopeful and haunting. As our explorations extend farther from Earth, from lunar expeditions to rovers exploring the Martian surface, one of the most transformative advancements in recent astronomy has come from the study of planets orbiting distant stars, exoplanets. Among these mysterious alien worlds, one name has surged to prominence: Proxima b. This exoplanet has captivated astronomers and astrobiologists alike because of its incredible proximity to our solar system. Orbiting the red dwarf Proxima Centauri, the closest known star to our Sun, Proxima b lies only 4.2 light-years away. This makes it one of the most reachable and fascinating candidates in the search for potentially habitable planets. The allure of Proxima b lies in its position within what scientists term the habitable zone, or Goldilocks zone, a narrow band around a star where temperatures could allow for the presence of liquid water on a planet's surface. Since water is essential to all known forms of life, the fact that Proxima b exists in this zone has ignited ongoing debates over whether this rocky world might host alien life. Still, Proxima b has not been easy to examine. The intense brightness and erratic behavior of its host star, combined with the vast cosmic distance, have long hindered detailed observation. Red dwarfs like Proxima Centauri are smaller than our Sun, but are far more active, frequently emitting powerful solar flares that complicate efforts to study nearby planets. For many years, ground-based telescopes could only provide minimal and murky data, leaving many questions unanswered. Everything changed with the launch of the James Webb Space Telescope, JWST, in December 2021. As the most sophisticated astronomical instrument ever deployed, JWST was built to pierce through the universe's dust and darkness using its advanced infrared sensors. From its orbit at the L2 Lagrange point, some 1.5 million kilometers from Earth, the telescope has been able to observe the cosmos with extraordinary clarity, free from Earth's atmospheric interference. In 2023, the JWST achieved a groundbreaking milestone. It delivered the most detailed image of Proxima b yet captured. For the first time, scientists could begin analyzing the planet's surface features and atmospheric layers. Thanks to its powerful near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, JWST detected possible traces of critical atmospheric components: water vapor, methane, and carbon dioxide. While these molecules don't confirm the existence of life, they are often considered possible biosignatures, chemical markers that, under certain conditions, may result from biological processes. Their presence has revitalized scientific interest and opened new questions. Could Proxima be home to life? Might we be closer to discovering another Earth-like world than ever imagined? There are, of course, significant hurdles. One of the primary concerns is the harsh stellar environment created by Proxima Centauri. The star emits frequent bursts of radiation, which could potentially strip away the atmosphere of a nearby planet. If Proxima b lacks a strong magnetic field or a dense enough atmosphere, it may be vulnerable to such hostile forces, making life as we know it unlikely. Scientists are now racing to determine whether Proxima b has any natural protection from this bombardment. Beyond its role in observing Proxima b, JWST is redefining the entire field of planetary science. One of its unique features is its ability to block a star's blinding light using a method called coronagraphy. By doing this, it can isolate the faint light reflected by orbiting planets, allowing astronomers to conduct highly detailed spectroscopic studies. These studies enable researchers to uncover clues about planetary atmospheres, weather systems, and even the possibility of seasonal changes. With this capability, JWST has transformed Proxima b from a theoretical object into a more tangible, living world. It has revealed temperature gradients, potential climate patterns, and atmospheric dynamics that were previously impossible to detect. This growing body of information is helping scientists evaluate the planet's ability to sustain life. Proxima b is not alone in this field of study. Other exoplanets located within the habitable zones of their respective stars, such as TRAPPIST-1e and Kepler 452b, are also under close examination. Each discovery contributes to a broader effort to understand how common Earth-like planets might be across the galaxy. Nevertheless, Proxima b remains exceptional due to its closeness to Earth. This proximity has positioned it as a likely target for the Breakthrough Starshot Initiative, a bold project aiming to launch miniature spacecraft using light-propelled sails. These probes, traveling at a fraction of the speed of light, could reach the Alpha Centauri system within a few decades, providing humanity with its first direct observations of another planetary system. But there's more to this mission than atmosphere and distance. Scientists are also investigating whether Proxima b might exhibit geological activity. A planet with a molten core and active tectonics can recycle essential elements and regulate its climate, both vital components for supporting life. The instruments aboard JWST are sensitive enough to detect volcanic gases and identify surface minerals, which may offer clues about the planet's internal structure and history. Simultaneously, astronomers are using colossal radio arrays, like the Square Kilometer Array, SK, to search for technosignatures, radio signals, or emissions that might suggest the presence of an advanced alien civilization. The search, while speculative, is a crucial component of the broader question. If intelligent life exists, how might we detect it? Despite the excitement, researchers urge caution. While methane and similar chemicals can indicate life, they can also arise from non-biological processes, such as volcanic activity or chemical reactions involving rocks and radiation. To confirm life, scientists must find multiple, overlapping lines of evidence, such as a consistent oxygen cycle or complex organic molecules. That's where NASA's upcoming Habitable Worlds Observatory, HWO, comes in. This future space telescope is being designed to follow in JWST's footsteps, but with an exclusive mission to detect and analyze potentially life-supporting exoplanets. It will build on JWST's legacy, using advanced coronagraphs and even larger mirrors to achieve unparalleled clarity. The HWO will go beyond atmospheric scans. It will directly image Earth-sized exoplanets orbiting distant stars and attempt to find combinations of molecules, like water, methane, and ozone, that, when present together, strongly suggest life. This leap forward in observational technology might finally offer the answer to one of humanity's oldest questions. Are we alone? What sets the HWO apart is not just its resolution, but also its durability. It's being engineered for long-term service, possibly allowing robotic missions or future astronauts to upgrade its instruments in orbit. This foresight means the observatory can evolve with new scientific questions and tech developments over the decades. The HWO will also function as part of a vast scientific alliance. It will coordinate with powerful Earth-based telescopes like the Extremely Large Telescope, ELT, and the 30-meter telescope, TMT, enabling a global network that combines resources and amplifies discoveries. Together, these tools may finally allow us to resolve whether planets like Proxima b are anomalies or part of a cosmic norm. Could the galaxy be full of Earth-like worlds teeming with life? Or is life a fluke, a rare cosmic miracle that makes Earth uniquely precious? Regardless of the answer, Proxima b is already reshaping our thinking. Its discovery and ongoing study challenge our assumptions about habitability and cosmic isolation. If life is found so close to Earth, it could imply that the universe is filled with living worlds. If not, it might underline just how fragile and unique our planet truly is. The James Webb Space Telescope's broader scientific mission reaches far beyond the study of exoplanets. While it has captured headlines for its potential to detect habitable worlds, its real power lies in its ability to transform our understanding of the universe's grandest and most mysterious phenomena. Among its most groundbreaking contributions is the insight it's providing into the formation of galaxies, the behavior of black holes, and the elusive nature of dark matter. With its unmatched infrared sensitivity, JWST can peer back over 13 billion years, capturing light that has traveled across space since the earliest epochs of the universe. These deep-field observations have revealed galaxies that are far more developed, structured, and luminous than scientists had expected to see at such early stages of cosmic history. Prior to JWST, The prevailing theories suggested that galaxies gradually evolved over billions of years, growing slowly in complexity and size. But the telescope's high-resolution images have challenged that assumption, showing fully formed spiral galaxies and bright galactic cores in the early universe. This has forced astronomers to rethink their models of galaxy formation, triggering new theories that may reshape our understanding of the cosmos. In addition, JWST is offering unprecedented views of black holes, particularly the supermassive ones that anchor the centers of galaxies. By analyzing the surrounding light and dust, astronomers can trace the feeding patterns and growth rates of these enigmatic objects. Meanwhile, the telescope's ability to detect gravitational lensing, where light from distant objects is bent by unseen mass, may help scientists map the distribution of dark matter, the invisible substance that makes up most of the universe's mass. In every direction it looks, the James Webb Space Telescope is rewriting the story of the universe, revealing that the cosmos is more dynamic, complex, and surprising than we ever imagined. But perhaps JWST's greatest gift is inspiration. Its images and data don't just fill scientific journals, they spark imaginations. School children, artists, and aspiring scientists are being drawn into astronomy in ways not seen since the Apollo era. The dream of interstellar travel, once the realm of science fiction, is slowly inching toward reality. Concepts like laser-powered light sails and nuclear propulsion are being tested and refined. If successful, these technologies could make missions to Proxima be feasible within the span of a human lifetime, a goal that seemed impossible only a generation ago. Yet with discovery comes responsibility. Should we find life on Proxima b, ethical questions will emerge. Should we try to communicate or quietly observe? Could our curiosity cause harm to fragile alien ecosystems? These are not only scientific matters. They demand wisdom from ethicists, policymakers, and society at large. The ongoing exploration of Proxima b is far more than an astronomical pursuit. It is a journey that touches on our deepest hopes and fears. It compels us to look beyond the stars and ask profound questions about who we are, where we came from, and whether we are truly alone. Each new atmospheric reading, each hint of geological activity, and each potential biosignature brings us closer to an answer. We are now standing on the threshold of a discovery that could change everything. And even if we find no life on Proxima b, our efforts are not in vain. Every insight we gain about other worlds feeds directly back into our understanding of Earth. By comparing climates, geological histories, and atmospheric dynamics, we can better forecast changes on our own planet and protect it for future generations. The data collected from Proxima b could be invaluable in refining climate models, understanding atmospheric erosion, and anticipating ecological tipping points. In trying to understand life elsewhere, we may gain the tools to preserve life here at home. The rising public interest in these discoveries is also changing how science is communicated. Documentaries, science channels, and educational programs are breaking down complex findings and turning them into digestible, exciting content that reaches audiences around the globe. A new generation of scientists, engineers, and space enthusiasts is growing up inspired by the possibilities Proxima b represents. It is no longer just a distant speck of light. It is a symbol of what we might achieve. The journey to Proxima b is, in many ways, a journey inward, toward understanding ourselves.